Unit 7, Lesson 6, Derivatives not with respect to time. When I say with respect to time, what I mean is this. For example, velocity. We know velocity is, say, dx over dt. What that really means is, what we're really saying is velocity is position x velocity is the derivative of position x with respect to time t. In our last few videos, we're usually talking about something over dt, especially in related rates. That's always like dx over dt, dc over dt, and so forth. Okay. But that doesn't have to be true. Okay. So more on notation in derivatives. If we have the function y equals x cubed plus 5x minus 2, then y prime equals dy over dx. We say that we are differentiating with respect to x. In real life, in the examples we've seen so far, we have y prime as dy over dt, c prime as dc over dt, e prime as de over dt, for example. It's always with respect to time. But it doesn't have to be. Let's look at two examples in which we're not differentiating with respect to time. Instead of dc over dt, we have dc over dx, or dc over something else, not t. Example 1. The kinetic energy of an object, Ek, in joules, is given by Ek equals 1/2 mv squared, where m is the mass in kilograms and v is the velocity in meters per second. In your last homework, you used this equation, but you looked at dE over dt and dV over dt. We're not going to look at dE over dt and dV over dt in this problem. Instead, A, for an object with mass equals 4, find E prime of v, which is equal to dE over dV. So this time we're looking directly at the relationship between energy and velocity, dE over dV. Okay, so we're differentiating both sides. So E prime, well, m is a constant, so it's going to be 1/2 times m. The derivative of 2v is 2v. Yeah. Notice that we don't have to do dv over dt because we're looking for dE. So technically what we did was really E prime is really equal to dE over dV, which is just equal to that. Another way of looking at it is we can say that dE equals 1/2 fm 2v times dV. That's from implicit differentiation. Therefore, dE over dV is 1/2 m times 2v, and dE over dV is our E prime, what we're looking for. Simplify 1/2 m times 2v, that's just 1/2 and 2 cancels, it's just mv. Okay. So the derivative of E with respect to v is just mv. So what is E prime of 20? Well, E prime equals mv. M we're told that is 4. V is 20, so E prime equals 80. In the last problem, if we note that m is 4, I guess the solution E prime is mv, which is also equal to 4v. Okay, C. Using correct units, explain the meaning of E prime of 20 in context. So we know that E prime is dE over dV. So the unit of E prime is going to be the unit of E divided by the unit of V. The unit of E is joules, J. The unit of V is meters per second. So the unit is going to be joules per meters per second. So E prime of 20, using our standard star that we have before, is the rate of change of E with respect to V, which is equal to 80, because E prime of 20 equals 80, and the unit is 80 joules per meters per second. So what it's really saying is that when the velocity increases by 1 meter per second, the energy increases by 80 joules. Okay. Example 2. A company is producing phones. The cost to produce n phones, C of n, is in dollars, is given by the following table. When n is 0, C of n is 40,000. That makes sense because there's startup costs. Even if you don't produce any phones, you still need to buy the equipment and so forth. Producing 1,000 phone costs $60,000, 2,000 phones $63,000, 3,000 phones $65,000, 4,000 phones $66,000. A. Use the information to estimate C prime of 3,500. We learned this from lesson 7.2. We can approximate using average rate of change. So C prime of 3,500 is approximately C of 4,000 minus C of 3,000 divided by 4,000 minus 3,000. So it's equal to 66,000 minus 65,000 divided by 1,000. Okay. This gets us, this is going to equal to 1,000 over 1,000, which is equal to 1. As it turns out, C prime of 3,500 is about 1. Explain the meaning of C prime of $3,500 in context. Well, the unit, first of all, unit is going to be a unit of C divided by a unit of N, which is dollars per phone. So what we're really saying here is the rate of change of C with respect to N using our sentence starter. C is the cost of producing phones with respect to the number of phones is equal to $1 per phone when we have produced 35 phones. So when we have already produced 35 phones, to produce one more phone, it only costs us $1 more. Okay. All right, that's it for this video.